Here we have a precalculus problem. Okay, let's go to the question. Use the binomial theorem to expand and simplify the expression 6x cubed negative y to the fifth power. So that is we have to expand this binomial and simplify. For that, let me consider a binomial that is a negative b to the nth power. Here I have taken negative sign between a and b inside the parenthesis because here we have negative sign in our binomial. Okay, there is a formula to get expansion of this binomial using binomial theorem. That is, we have to take this n in a combination, that is nc0. And now we have to consider this a, and this a has to be raised to the power of n, and we have to take this b, and this b has to be raised to the power of 0. So for a, we take this n as exponent, and for b, we have taken this 0 as exponent over here. Since we have negative sign over here, for the second term, we have to take negative sign. That is, in the formula, we have to take positive sign and negative sign alternatively. For the first term, we have to consider positive sign. For the second term, we have to consider negative sign. For the third term, we have to consider positive sign. In this way, we have to consider positive and negative sign alternatively. Okay, since I have taken NC0 as a coefficient of the first term, the coefficient of the second term is NC1. That is, we have to add 1 to this 0. And now we have to subtract 1 from the exponent of a, then we get a to the power of n negative 1. Now we have to add 1 to the exponent of b, then we get b to the power of 0 positive 1 is 1. So the same thing we have to do. We have to add 1 to this value and subtract 1 from the exponent of a, add 1 to the exponent of b. Now for the third term, we have to consider positive sign because we have taken positive sign for the first term, negative sign for the second term, and for third term, it has to be positive. Okay, now the coefficient has to be NC. Now we have to add 1 to the value of R in the combination. When I add 1 to this one, I'm getting NC2. And now I have to subtract 1 from the exponent of a. When I subtract 1 from n negative 1, I'm getting n negative 2. And now I have to add 1 to the exponent of b. When I add 1 to the exponent of b, I'm getting b square. Okay, now I have to take a negative sign for the fourth term because the previous term has positive sign. Now the coefficient has to be NC. Now we have to add 1 to this R, then we get NC3. Subtract 1 from this n negative 2, then I'm getting n negative 3. Add 1 to this 2, then I'm getting B3. And we have to keep doing this until we get the term where the value of n and r in the combination has to be same. So here we have n, here we have n. Okay, now what should be the exponent of a? Now look at the pattern of the term we have over here. So when we have 3 as a value of r, the same 3 has been subtracted from n at the exponent of a, and the same 3 has been taken as the exponent of b. Even when I look at this term, the same pattern will be having. So here the value of the r in the combination is 2. The same 2 has been subtracted from n. The same 2 has been taken as exponent b. So here at the place of r in the combination is n. So this n has to be subtracted from n at the exponent of a. The same n should be taken as exponent for b, then we get b to the nth power. Okay, now I'm going to use this formula to get the expansion of the binomial we have over here in our problem. Okay, let me write it 6x to the third power negative y to the fifth power. Okay, so here comparing this and this, at the place of a we have 6x cube, at the place of b we have y, and at the place of n we have 5. Okay, for n we can plug in 5, that is 5c0. For a we have 6x to the third power to the fifth power. Let me write over here, and y to the power of 0. Here we have 6x cube at the place of a. Since a has been raised to the nth power, I have raised 6x cube to the fifth power because we have 5 at the place of n. And we have y at the place of b. Since b has been raised to the 0th power, I just raised y to the 0th power. And for the second term, I have to take negative sign, and nc1 means 5c1. And for a, again, we have 6x cube, n negative 1. For n, we have 5. Negative 1, and for b we have y, so that is y to the first power. Okay, for third term we have to take positive sign. nc2 means 5c2, and for a we have 6x to the third power, n negative 2, that means 5 negative 2, and for b we have y. Since we have b square, we have to take y square. And now for the next term we have to take negative sign, positive, negative, positive, negative. Okay, so nc3 means we have 5c3, 6x cube to the power of n negative 3, that is 5 negative 3. Let me write it. And b to the third power means that is y to the third power. So here I have negative sign. So now the next term has to be positive. 5c4. We have 6x to the third power raised to the power of 5 negative 4, and y to the fourth power. Since this one is positive, the next term has to be negative. 5c5. 6x to the third power raised to the power of 5 negative 5. and y has to be raised to the fifth power. Okay, now in this term, since we get the same value for both n and r in the combination, we have to stop it. And now we have to do simplification. Okay, before we start simplifying the terms we have over here, let's understand some stuff on combinations. That is, let's consider an important property of combination, that is NCR equals to NC n negative r. So the value of this combination, the value of this combination, both of them are equal. Usually we use this property if the value of r can be decreased. For example, let's consider 10C7. If I use a property over here in this combination 10C7, what will happen? 10C 10 negative 7, that is 10C 3. So the result of this combination and this combination are equal. So when I use the property in this combination 10C7, the value of r has been decreased. So if there is a chance to decrease the value of r, the calculation process will be easier. In that case only we have to use this property. Otherwise we should not use this property. For example, if I use this property in the combination 25C 3, what will happen? Then we get 25C 25 negative 3. Then I'm getting 25C 22. When I use this property in this combination 25C3, the value of r has been increased from 3 to 22. It will increase our calculation burden. So we should not use this property in this kind of combinations. So if there is a chance to decrease the value of r, we can use this property. Otherwise, we should not use the property. And also now let's find some shortcut to get the value of a combination. For example, if I want to get the value of the combination 10C3, how can we evaluate this one? And we don't have to use a property I've explained over here in this combination. If I use this one 10C 10 negative 3, 10 negative 3 will be 7. So the value of r has been increased. We don't want to use the property over here. Okay, how to get the value of this combination? For that, what we have to do is we have to reduce the value of n, that is the value of this 10 has to be reduced for the next 3 integers and multiply them. So why do we reduce this 10 for the next 3 integers? Because here the value of r is 3. So that's why I'm saying this 10 has to be reduced for the next 3 integers. Then we get 10 times 9 times 8. Now it has to be divided by the factorial of this number, that is 3 factorial. 3 factorial means that is 3 times 2 times 1. So here 3 goes into 3 1 times, 3 goes into 9 3 times, 2 goes into 2 1 times, 2 goes into 8 4 times, 4 times is 12, 12 times 10 is 120. So the value of this combination is 10C3. Okay, now let's look at another example, that is 10C4. So here we have the value of r is 4. So this 10 has to be reduced for the next 4 integers, that is 10 times, 9 times, 8 times 7 divided by 4 factorial. 4 factorial means 4 times 3 times 2 times 1. So 2 times 4 is 8 and 8 will cancel. 3 goes into 3 1 times, 3 goes to 9 3 times. 3 times 7 is 21. 21 times 10 is 210. So 210 is the value for the combination 10C4. Let's know some more stuff on combination. Let me consider a combination where the value of r is 0 and also where the value of r is also the same as n, that is NCN. Okay, in a combination, if the value of r is 0, then the value of that combination is just 1. In a combination, if the value of n and r, both of them are equal, then its value is also 1. For example, if I say 5C0, its value is equal to 1. And 5C5, this is also equals to 1. Because in this combination, the value of r is 0, so its value is just 1. In this combination, the value of n, the value of r, both of them are same. So the value of this combination also 1. And now let me consider a combination where the value of r is just 1. Okay, now in this combination, the value of r is 1. In a combination, if the value of r is 1, so its value is whatever value we have over here, that is n. Okay, now we can use the stuff on combination we have discussed so far to get the values of the combinations we find over here in the expansion of the given binomial. Okay, we know that the value of 5C0 is just 1 because the value of r in this combination is 0. So 1 times, and here 6 and x cube are multiplied and we have the exponent 5 in common. Whenever two terms are multiplied and we have the common exponent, the exponent can be taken separately for each term and multiply the results, and I'm getting 6 to the 5th power. Then we get x to the 3rd power to the raised to the 5th power, and the value of y to the 0th power is just 1. Anything raised to the 0th power equals to 1, negative. In this combination, the value of r is just 1. Then the value of this combination is the value we have at the place of n, that is 5. So 5 is the value of this 5C1 times 6x to the 3rd power raised to the power of 5, negative 1 is just 4, and y to the 1st power is just y, positive. Now let's find the value of this combination 5C2. And let's use the property that is NCR equals to NC n negative R over here in this combination. If there is any chance to decrease the value of R, so then if I use the property over here, phi C, phi negative 2, phi negative 2 is 3. When I use this property in this combination phi C2, the value of R has been increased. So there is no use of using this property over here in this combination. Okay, now let's evaluate the value of this combination. Since the value of R is 2, this phi has to be decreased, reduced for the next two integers, that is 5 times 4, and it has to be divided by the factor of this number 2 factor, that is 2 times 1. 2 goes into 2 one times and 2 goes into 4 2 times. Then we get 5 times 2 is 10. 10 is the value of this combination phi C2. Okay, now let me plug in 10 for this phi C2 over here. Then I'm getting 10 times 6x cube raised to the power of phi negative 2 is just 3. Y to the second power negative. Let's evaluate the value of this phi C3. Let's use the property already we have discussed, and we get phi C, phi negative 3. So phi negative 3 is just 2. When I use the property, the value of R has been decreased from 3 to 2. And already we know the value of phi C2. We got it over here. Its value is 10. So equals to 10. So the value of this phi C3 is also the same value of phi C2, that is 10 times 6x to the third power raised to the power of phi negative 3 is just 2, y to the third power positive. Now let's evaluate the value of this phi C4. Let me use the property we have over here. Then we get phi C, phi negative 4. Phi negative 4 is just 1. Okay, when I use the property, the value of R 4 has become 1. And since the value of R is 1 over here in this combination, its value is the value we have at the place of n, that is 5. So the value of phi C4 is just 5. So we can plug in 5 for this phi C4 times 6x to the third power raised to the power of so phi negative 4 is just 1, and we have y to the fourth power negative. So here in this combination, the value of n, the value of r, both of them are equal. The value of such combination is just 1, and 6x to the third power phi negative 5 is 0 times y to the fifth power. Okay, now so here let's write this one as it is. 6 to the fifth power. Let's evaluate the value of 6 to the fifth power. So then we get 7776 times, and here we have base x, and we have exponent 3, and for this complete stuff we have exponent 5. Whenever we have two exponents like this, what we can do is we can multiply the two exponents. Then I'm getting x to the 15th power times 1 and negative 5, and here 6 and x cube are multiplied, and we have the exponent 4 in common. So the exponent can be taken separately for this 6 and x cube. Then I'm getting 6 to the 4th power, x to the third power to the 4th power times y positive 10 times. The same thing we can do here, that is 6 to the third power times x to the third power to the third power times y square, negative 10 times 6 square times x to the third power the whole square, y cube positive 5 times 6x cube raised to the first power is the same, that is 5 times 6x to the third power times y to the fourth power, negative 1 times anything raised to the 0th power is equals to 1. So the value of this 6x cube raised to the 0th power is just 1 times y to the fifth power. Okay, here now we can multiply 7776 and this one. When I multiply these three numbers, I am getting 7776, and we have x to the 15th power, and we have negative 5 times we have to get the value of this 6 to the 6th power. So that is 6 to the 6th power is 1296, and here we can multiply these two exponents, and I'm getting x to the power of 3 times 4 is 12 times y positive 10 times we have to get the value of this 6 to the third power. Its value is 216 times x to the power of 3 times 3 is 9, y square negative 10 times the value of 6 square is 36 times x to the power of 3 times 2 is 6, then y cube positive 5 times 6 is 30, x to the third power, y to the fourth power, negative 1 times 1 is 1, 1 times y to the fifth power is just y to the fifth power. We have 7776 x to the 15th power negative. When I multiply this 5 and 1296, I'm getting 6480 x to the 12th power times y positive. When I multiply this 10 and 216, I'm getting 2160 x to the 9th power times y square, and negative. When I multiply this 10 and 36, I am getting 360 x to the sixth power y to the third power, positive 30 x to the third power y to the fourth power, negative y to the fifth power. Okay, now I got the expansion of the given expression and also simplified using a binomial theorem. So this is the expansion of the given expression.